Welcome to The Explainer. Today, we're diving into some really cool research about the next generation of AI. And it turns out the key to helping robots finally understand what we're doing isn't just about giving them better eyes, but something way more human, a memory. You've seen the videos, right? A super advanced robot trying to do something simple, and it just looks clumsy, awkward. It gets the basics all wrong. So how is it that these incredibly powerful machines can perform complex surgery but still get totally confused by just, normal human stuff? Well, the answer to that question gets right to the heart of a massive blind spot that robots have when they look at us. It's a fundamental challenge in human-robot interaction, and it really all comes down to one thing. Okay, so here's the problem in a nutshell. A robot can track your arms and legs with insane precision. But what it can't do is tell the difference between two actions that look almost exactly the same. For example, the motion of lifting a napkin off a table looks a lot like the motion of just standing up from that table. To a robot's eyes, they're basically the same movement. It sees what you're doing, but it completely misses the why, the intent. And this whole problem exists because of this big trade-off in how we currently build robot vision. On one side, you've got what are called skeleton models. They are fantastic at capturing your body's motion, every joint, every limb, but they're completely blind to the world around you. They can't tell if you're raising your hand to wave or to drink because they literally don't even see the glass. Then on the other side, you've got contextual models, and they're the exact opposite. They see the whole scene, the table, the chair, the glass, but they're kind of fuzzy on the specific action you're taking. So you're stuck, right? You either get precision without context or context without precision. Neither one is good enough. So how do we fix this? Well, according to this new research, the solution isn't about giving robots better eyes. It's about giving them a better brain, and specifically, a brain with a memory. The researchers are building what they call an agentic AI, and this is a huge leap from the AI we're used to. We're not just talking about a machine that follows a pre-programmed script anymore. An agentic AI can actually perceive what's happening, reason about it, and, this is the most important part, learn from its experiences to get better over time. It's all about creating an AI that can actually adapt. And what's the one thing that unlocks this incredible ability to learn and reason? Well, the secret ingredient, the real game changer here, is memory. Just like for us, memory is what gives an AI the context and the experience it needs to make sense of what's happening right now. This new system actually has two types of memory. The first one is short-term memory, or STM. The best way to think about this is like a detective's little notepad during an investigation. It's just jotting down what's happening, frame by frame, connecting what you were doing a second ago to what you're doing right now. And then you've got long-term memory, or LTM. Now, if the short-term memory is the notepad, the long-term memory is the detective's entire library of old case files. It's this huge collection of past experiences that the AI can pull from to understand a new situation by saying, hey, have I seen something like this before? Okay, so we've got an agent with two kinds of memory. Pretty cool. But how does it all actually come together? Let's break down how this AI really thinks step by step. It's actually a really elegant four-step process. First, it senses the world, and it's taking in both the video of the scene and that super precise skeletal data at the same time. Then it starts to reason, using powerful language models to describe not just the movement, but everything happening around it. Step 3 is where the magic happens. Remember. It takes what it's seeing now and compares it to its short-term memory of the last few seconds and its long-term library of everything it's seen before. And finally, based on all of that combined information, it makes a prediction, a much, much smarter guess about what you're actually trying to do. This all sounds fantastic in theory, right? But the real question is, does it actually work out in the wild? So the researchers put this new memory-driven system through its paces to see if it really made a difference. And the results? Well, they were pretty powerful. Remember that whole problem of telling the difference between standing up and lifting something? By using its memory, the agent could see the entire action, from sitting to beginning to stand to interacting with a napkin and figure it out. It literally refined its own guess in real time. That's a big deal. So let's look at another test that's really telling. This time, on data the AI had never seen before. A person just standing and reading a book. The old school model, the one that only looks at motion, gets completely lost. Its best guess? Cleaning. I mean, it's not even close. But now, let's look at the agentic AI's guess for the same scene, carrying an object. Now, okay, it's not perfect. It didn't say reading a book, but it's so much closer to the truth. It understood the most important part of the action. A person is holding and interacting with an object.
That right there is the power of combining motion, context, and memory.
But the hard data? Man, that's where the story gets really compelling. When tested on activities that had never seen before, the old models were only right about 35% of the time. The models that only used context did a little better, at 40%. But the new agentic AI, the one that combines everything with memory, it hit 60% accuracy. That's not just a little better, that is a massive leap forward.
So what does a 20-point jump in accuracy actually mean for us in the real world? This is maybe the most important question because it gets at why this kind of research is so critical for our future.
Well, the implications are pretty huge. For assistive robotics, this is the difference between a robot that helps an elderly person up when they need it versus one that gets confused when they're just reaching for the TV remote. In healthcare, it could mean a system that knows the difference between a patient reaching for life-saving medicine or just a glass of water. It means safer, more seamless collaboration in factories, and really, it all comes down to this. The better robots get at understanding us, the better we'll get at trusting them.
Now let's be realistic here. The researchers are the first to say that this is still early days. The system is incredibly complex, and getting it to run in real time without any lag is a huge hurdle they still need to figure out. Think of this as a really promising proof of concept. There's still a lot of work to do.
And that really leaves us with one final big thought to chew on. This research is a critical step towards robots that can finally grasp what we're actually trying to do. But as they get smarter and learn to understand our world, it raises a brand new question for us to answer. How will we learn to understand and ultimately to trust them?